Hello, dear students. In the previous lectures, we learned the integral calculus in that reduction formulas. Now, today's lectures, we are going to learn the one more important sub part of that integral calculus, that is gamma function. That is gamma function. Gamma function has wide applications to calculate the integral of the functions, which are different types of integrand, and the limits of the intervals are different ranges, the finite or infinite ranges also. And that time, how to evaluate the integration of the given complicated integrand functions, complicated exponential logarithm functions, exponential logarithm functions, mix of the both fraction functions. Integrand are the different types of fractions, mixed fractions, exponential, logarithmic, and with limits 0 to infinity, how to solve such types of integral. Now, first I'll define what is meant by gamma function. Now, definition of gamma function, I'll explain you what is meant by gamma function. Now, a definite integral, the definite integral 0 to infinity, integral 0 to infinity, e raised to minus x raised to n minus 1 dx, and this is a definition of gamma function, and denoted by gamma n. Gamma is symbol gamma n. The number n is obtained from this power of x. Power of x is added by 1 and you get a gamma function. E raised to minus x, here also x is variable, here also x is variable, and this integral we call it as gamma integral 0 to infinity e raised to minus x raised to n minus 1 dx. Here again both the integrands e raised to minus x and x raised to n minus 1 are infinitely integrable functions and infinitely differentiable functions, and depending on n we get. Therefore, here the number n is always positive, it's greater than equal to 0, and this is a formula for gamma function, integral formula for the gamma function. Now, there are some important property of the gamma function. Then we'll go to next point, next slide. Now, the important properties, we can call it as properties of gamma function. Gamma function. The most simple important properties, and when we are solving these integral equations to calculate area, volume, integral, center of mass, moment of inertia, center of gravity, and so many concepts, that time you required such types of integrals to evaluate the integrals. Now, during that we get such types of equations and we have to solve it. Now, first important formula is there, gamma 1. If you replace n by 1 in the integral equations, we get value gamma n equal to 1. Gamma n equal to 1. Sorry. Now, second, gamma n also can be written as gamma 1 can also written as n minus 1 into gamma n minus 1. That is, if gamma n plus 1 is in the gamma function, then n into n minus 1 n into gamma n with its a formula. Now, next is the what is value of gamma n plus 1 in terms of factorial is equal to n factorial. N factorial means when you are converting factorial number, suppose here 3 factorial is there, 3 factorial is nothing but 3 into 2 into 1, and this 3 factorial also can be written as in terms of gamma function equal to gamma of 4, gamma of 4 in the reverse order. Gamma of 4, while converting into factorial form, you can reduce one number and write down in terms of factorial form. That is gamma of n plus 1 is equal to gamma n. Now second important point, then gamma of 0, gamma of 0 equal to infinity. Sorry. Gamma of 0 equal to infinity. This is a important formula, or you can say its value of the 0 in terms of gamma function, gamma 0. Now next is gamma of half, gamma of 1 by 2. Now these are all the values. If you put into that integral formula, you get these values. Gamma half is nothing but root pi. Then after that we have the important formula gamma is second kind, you can also say gamma n also can be evaluated by its integral formula 2 times integral 0 to infinity e raised to minus x square x raised to 2n minus 1 dx. This is also called as a second kind of gamma function, second form of the gamma function. Where in the gamma function we have here only e raised to minus x. Now we have e raised to minus x square. To convert this integral into standard gamma function, if you can replace x square equal to t, then you can get the standard form. Now after these properties, after these important properties, there are some important forms of gamma function. Then we call it as transformations of gamma functions. Transformation of gamma function. Gamma functions. There are some standard formulas, you can say also these gamma functions. In that first one, integral 0 to infinity e raised to minus kx x raised to n minus 1 dx equal to gamma n upon k raised to n. Here you can see how this formula is obtained. Now here the standard formula is k equal to 1. K equal to 1, you get the gamma function. If in place of e raised to minus x, if any other number is there k, that time this gamma function can be written as that gamma n upon k raised to n. This is one important, so you can type or you can transform into gamma functions. Now second, integral 0 to infinity e raised to minus y raised to 1 upon n, means nth root of x y dy is same as n into gamma n, n into gamma n, and this is also same as gamma of n plus 1, gamma of n plus 1 e raised to minus y raised to 1 upon n, means nth root of y. Now whenever such cases arises in the integrand, then I'll give you in the next slide how to reconvert these all the integrals into standard integral formulas. Okay, in next slide we will check. Now third property, gamma n also can be written as integral 0 to 1 log of 1 upon y raised to n minus 1 dy. Gamma n also can be written as integral 0 to 1 log of 1 upon y raised to minus n minus 1 dy. These are the important transformation you can say. One more I'll define here. Fourth one. Integral 0 to infinity e raised to minus ax raised to n, means here k also there and x raised to n also there, that format. Dx equal to 1 upon n, again 1 upon nth root of a, means a raised to 1 by n, and gamma of 1 upon n. This is one of the important formulas. Now there are some important tricks here how to convert the given examples in terms of standard evaluated form or convert them into gamma integral form by using these three concepts. Now here I am giving you some important tricks how to convert these integrals or given integral into gamma integral form. Now first one, integrand containing 0 to infinity e raised to minus ax raised to m dx. This is one form. Then I'll use different sketches for the different forms. Second form, integral 0 to infinity 1 upon a raised to x into dx. And third form, integral 0 to 1 log of 1 upon x or log x. These forms how we are going to solve. Just I'll show you the hint for this all the forms. Most of the examples of these three forms, okay, all the examples which are important for the gamma functions, they can convert into these three forms. These three forms are important in a gamma function. Now such cases, if integrand is like this given to you, in such cases here you need to substitute, put here ax raised to m equal to some another parameter, say t, means whatever the power of exponential is there, this power of exponential you have to put equal to another parameter t, another parameter t. Now for the second one, now such cases here what is to put, replace a raised to x is equal to e raised to t. A raised to x can be written as e raised to t. Now this substitution helps to you convert the integrand equations in terms of directly soluble form. Now here you can put log of 1 upon x equal to t, or you can say log of x equal to minus t. You can replace log x equal to minus t. I'll show you one by one examples. Now suppose a first form here, how they ask question, examples form, I'll take it here. I'll take one examples for this type. Integral 0 to infinity e raised to minus x raised to 4 dx is given to you, and how to evaluate such types of integral. Now this is a first type. Replace what is the power of exponential must be into another parameter. In such cases, if you replace here, put x raised to 4 equal to t, x raised to 4 equal to t. Therefore x equal to t raised to 1 by 4, t raised to, by taking fourth root on both sides, x equal to t raised to 1 by 4. Now you can differentiate it. Tx equal to 1 upon 4 t raised to 1 by 4 minus 1 into dt. 1 by 4 into minus 1. Therefore, and this you get by simplification, dx equal to 1 by 4 as it is, t raised to 1 by 4 minus 1 means that is minus 3 by 4 dt. Now after substitution, check the limits. What are the changes in the limits? Now I'll just show you how to check the limits. Here, as x is given to x equal to 0, then what is our value of t, new value? Now here our equation is substitution is there, x raised to 4 equal to t. Then put x equal to 0 here, you get t equal to also 0. And if put x equal to infinity, then t also tends to infinity. Then the given integral becomes integral again, integral I equal to, you can say 0 to infinity, no change in the limits, e raised to minus t, minus in the replace here x raised to 4 equal to t, you get e raised to minus t, and dx equal to this whole pattern means 1 by 4 t raised to minus 3 by 4 dt, minus 3 by 4 dt is equal to, now you can simplify it, 1 by 4 you can take outside constant, integral 0 to infinity e raised to minus t, t raised to minus 3 by 4 into dt. Okay, this is simplified form, and we got is a standard form of gamma function. Standard form of the gamma function, 1 by 4 as it is, it's a gamma of whatever power of t there, that power is added by 1, that is gamma of minus 3 by 4 plus 1 is same as 1 by 4 into gamma 1 by 4, 1 by 4 into gamma 4. Like that, examples, any integral, you can use this 3 standard substitution method, then you get integral will be converted into standard form. Now we'll see the second example, that example of the form, second format. Suppose if they ask you evaluate the integral 0 to infinity x raised to some number, say 5 upon a raised to x, or you can say 5 raised to x. I'll write here this a equal to 5, then 5 raised to x dx, x raised to 5 raised to x. Now such cases, again by the second rule, we have to convert these integrals into integral as a gamma function form. Integral I equal to integral 0 to infinity x raised to 5 upon 5 raised to x dx. Now again here we have x raised to 5, put x raised to 5 equal to e raised to t, e raised to t. Now you can replace x 5 raised to x equal to e raised to t. Now to simplify it, take log on both sides, you get x log 5 equal to t. By taking log on both sides, you get t equal to x log 5. Therefore, then you get x equal to t upon log 5. Differentiate it, you get dx equal to 1 upon log 5 into dt. Now here I have to check again limits. What limits you going to change by substitution? One, as x tends to 0, here 5 raised to 0 means 0 into something is 0, therefore t also tends to 0. You can put any here, either here or here. You can put either x equal to 0 here or here. You get t equal to 0. Now here again x equal to infinity, then t tends to infinity. Therefore, no change in the limits. Now given integral I can written as integral 0 to infinity x raised to 5 keep as it is. X raised to 5 you can keep as it is, other can convert this into x in term form. X raised to 5 is t upon log 5, t upon log 5 raised to 5 raised to 5 into e raised to minus t. Now if here x raised to 5 is in the denominator and it comes into numerator, it becomes minus t, e raised to minus t. Now in place of dt you can write this value is 1 upon log 5 into dt. Now simplify this integrand with the index of the proper one, 1 upon log 5. Here is log 5 raised to 5 and here one more log 5 raised to 6. Log 5 raised to 6. Integral 0 to infinity. Integral 0 to infinity t raised to 5 for the first bracket, t raised to 5 e raised to minus t, e raised to minus t into dt, into dt. Now our integral becomes in standard form of gamma function. This is gamma function here, e raised to minus x into x raised to n, x raised to n formula. Then this can be written as is equal to 1 upon log 5 raised to 6 keep as it is into this is here what is the power of t increase by 1 and write into gamma function. This is gamma of 5 plus 1 means 6, gamma of 6. Gamma of 6 is nothing but 5 factorial. You can write this in factor form also, 5 factorial upon log 5 raised to 6. This is your required integral for the given function. Like that you can solve any integral by using that substitution, the important substitution method. These three you have to keep in mind. Now we will see one more examples of this type and how to convert them into integral 3. Integral 0 to infinity 3 raised to minus 4 x square dx, x square dx. Now such integrand we can convert into gamma function form. Now assume that I equal to, let us assume that I equal to integral 0 to infinity 3 raised to minus 4 x square dx. Now we have exponential power also here and it is apart from e, therefore directly you can replace, otherwise you can go into two steps. Okay. Now I'll go directly substitution method. Now I'll substitute here directly. If you replace this whole integral equal to e raised to minus t 3 raised to minus 4x square equal to e raised to minus t. Take log on both side, take log on both side, you get 4x square, 4x square into log 3 equal to minus t, equal to minus t. Now you can stick both side plus minus sign, then you get here x square equal to t upon 4 into log 3, x square equal to t upon 4 into log 3. Therefore x also you can write taking root on both sides, x equal to t raised to 1 by 2, t raised to 1 by 2 root of 4 is 2 into log 3 raised to 1 by 2 means again root of this one 1 by 2. Now you can differentiate it, dx equal to 1 by t 1 by 2 t raised to 1 by 2 minus 1 means minus 1 by 2. The remaining constant as it is. This is here 2 as it is. Log root 3 log of 3 raised to 1 by 2 also as it is. Now check the limits. Now check the limits. Here I'll use here different sketches for the checking limits. As we put x equal to 0, put x equal to 0 here, e raised to 0 becomes 1, then here also same thing, then t becomes also 0. And as x tends to infinity and t tends to infinity, then our given integral it becomes integral I equal to integral 0 to infinity e raised to minus t into, now you write dt value t raised to minus 1 by 2 into 1 by 2 into 1 by 2 log 3 ka root, that is raised to 1 by 2 dt, that is 1 by 2 dt. If you simplify it, you get here 1 by 4 outside, you can take 1 by 4 outside, log of 3 raised to 1 by 2, that is root of log 1 by 3 log 3 we can take outside. The remaining integral 0 to infinity e raised to minus t and t raised to minus 1 by 2 dt, and this is again you get standard form of the gamma function. This standard form of gamma function, and this equal to 1 by 4 is root of log 3 into, this is our gamma function what we are going to get for the standard gamma function. This is gamma. If you add in that number by 1, minus 1 by 2 plus 1, you get plus 1 by 2, and we have gamma of 1 by 2 is equal to root 5 by 2. Gamma of 1 by 2 is root pi by 2. Sorry, it's root 5. Therefore, integral I equal to get root pi here, you put here root pi upon 4 into root of log, like this. So any complicated integral, if you use to solve by using that standard substitution, you get exactly value what you required for the integrals. Now we'll move to the one log examples. One examples of example containing log. Example number 3. How to solve such types of equations. Now we'll take one example. Suppose integral 0 to 1 x into log x raised to 3 dx, x into log x raised to 3. Now such equations, first assume that given integral I, first assume that, let us assume that I equal to given integral, write into proper way, 0 to 1 x log x bracket raised to 3 dx. Now if you split it in the proper way, you like this, you get x 0 to 1 x raised to 3 and log x raised to again 3 dx, again 3 dx. Now such cases, now here you replace log x equal to, I'll take here you can replace, put log x equal to minus t, log x equal to minus t. To remove log on both sides, take exponential power x equal to e raised to minus t, x equal to e raised to minus t, and differentiate it, dx equal to minus e raised to minus t dt. e raised to minus t derivative is e raised to minus t into minus 1. That's why here is minus 1 e raised to minus t. Now our important part is here checking of limits. Checking of limits. Now as here you check here our old variable and new variable. New variable is t, old variable is x. As x tends to 0, log 0 you get infinity. Log 0 you get infinity. Log 0 infinity. Then as x tends to 1, log 1 you get 0, then t tends to 0, log 1 is 0. Then our integral becomes integral I equal to, here 0 is replaced by infinity, means integral infinity to 0, infinity to 0, and x here x raised to 3 there is e raised to minus 3, you get e raised to x is replaced by this value e raised to minus t, e raised to minus t bracket raised to 3, bracket raised to 3, and here minus t raised to 3, here dt again minus e raised to minus t into dt. Now after simplification of this term we get like this form, integral I equal to, here minus sign, both the minus signs you can convert it into positive, this minus sign, I have minus 1 raised to 3, I'll write one more step here, you get integral 0 to infinity with change of sign. Here I'm changing sign by change of integral here. Here 0 to infinity there, and here we have infinity to 0. I'm writing here 0 to infinity by changing the sign. E raised to minus 3t, e raised to minus 3t, t raised to 3 into minus 1 raised to 3, again e raised to minus t into minus 1 dt, into minus 1 dt. Now I can stick this minus sign here, minus 1 raised to minus 3 means minus 1, and here also minus 1 becomes a plus sign, and now exponential power you can collect together. Integral I equal to, here you get integral I equal to limits 0 to infinity e raised to minus sign is there, e raised to minus t, and here minus 3 you get minus 4t, t raised to 3 dt, t raised to minus 3 dt. Now again here we have 4t, you have 4t. I'll go to next slide and I'll show you how to convert this 4t. Now I got here integral I equal to, you can check here what you got in previous example, integral I equal to minus integral 0 to infinity raised to minus x minus 4t dt. And I'll go to next slide here, you get integral 0 to infinity with minus sign e raised to minus 4t, t raised to 3 dt. You can check e raised to 3 4t minus 1 minus sign. Now here is not in standard form, then again you can change, or you can write down this is equal to one more parameter, you put 4t equal to u, or x also return back 4t equal to u, means t equal to u upon 4. Now when t tends to 0, u also tends to 0. When t tends to infinity, u also tends to infinity, means new limits are not changing. Integral minus sign 0 to infinity e raised to minus u, e raised to minus u, then here t is nothing but u upon 4 raised to 3, and dt you get du by 4, du by 4, you can differentiate this one, you get dt equal to du by 4. Now integral I equal to, now here minus sign as it is, here 1 upon 4 raised to 3, and here one more 4 is there, means 1 upon 4 raised to 4 integral 0 to infinity e raised to minus u and u raised to 3 du. Again, this you got in the standard form of the gamma function. Then how is standard form? X e raised to minus x raised to 3 is equal to, we get answer minus 1 upon 4 raised to 4 gamma of, this is your value, this value you have to add 1, means gamma 4. This is a gamma 4. Like that you get value of any integral in the form by reduction by substituting the values. I'll repeat once again all the here substitution methods. Now this is our important gamma functions. This is a integral 0 to infinity e raised to minus x raised to n minus 1 dx. This is a formula for gamma function. This standard formula you can say our integral formula of gamma function. And here is x is variable, you can change that x equal to any variable, you can get the answers. Okay, this is first one. Now second slide I'll go. These are some properties. Gamma 1 value is 1, gamma n equal to n minus 1 into gamma n. There is n, gamma n plus 1 equal to n into n minus 1. And second, you can go here, gamma of n plus 1 is same as factorial n value, factorial n, and gamma 0 equal to infinity. These are the very important values or property you can say of the gamma properties. Now here, gamma of 1 by 2 equal to root 5. These values we are going to use while calculating the integrals. Now these are the three transformations. Means now just I told you, when you even that last example also you can solve with this method, x raised to n minus 1, that you, k is there, k raised to n, you can substitute using gamma 4. Now this here y raised to means nth power of y is there, root of y, nth root of y. These are the different forms of trigonometric integral calculus, and you can convert them into also by using substitution method. Now to convert them, we have these three important substitution. These three important substitution, how to, when to use what substitution. This is the first form. Whenever integrand having e raised to minus ax raised to m dx, then that time you have to put here ax raised to m equal to t, means exponential power. What is that? All power you can put equal to t. Then in the second form, integral 0 to infinity 1 upon e raised to x dx, means here we required e raised to minus x, that's why this is whole replaced by e raised to x, e raised to x. This is a simple substitution. We need e raised to minus x in the formula, that's why. Now here log terms, integral 0 to 1, whenever integrand containing log, put log x equal to minus t. Whenever integrand containing log, then put log x equal to minus t, then directly you get values. And whenever you are substituting these values, you have to check corresponding limits also. Okay. Then like that you can solve any examples. Here these are some examples of which are shown for each type. Okay, then if you have any queries, any this one, you can visit mine all the videos, then you get series of videos one by one, then you get clear idea how to get the instructions. Now we stop here. In the next lectures we are going to learn the beta function.